Hi, my name is Hermann Arngrímsson, a radar engineer in the observations department at the Icelandic Meteorological Office. In this video I'm going to tell you how we use the weather radars in volcanic events. A radar engineer is responsible for the quality of the measurements from the weather radars. This is done with regular maintenance and calibration of the instruments. A weather radar is used to locate precipitation, calculate its motion, and estimate its type. Thus rain, snow, hail, or even volcanic ash. Weather radars are pulse Doppler radars, thus capable of detecting motion, in addition to the intensity of the precipitation. Both types of these data can then be analyzed to determine storm structures and their potential to cause severe weather. A modern weather radar can transmit in dual polarization. Targeting with dual pol will reveal the form of the particles. If two pulses are sent simultaneously with orthogonal polarization, thus one is vertical and one is horizontal, two independent sets of data will be received. These signals can be compared in several useful ways, giving us more information about particle shape. Dual polarization radars can more easily distinguish volcanic ash from precipitation, making it easier to locate the ash cloud. Here at the IMO we have 4 weather radars. They are constantly scanning and sending us data every 5 minutes. 2 of these weather radars are fixed weather radars, currently being upgraded to modern dual polarization systems. The other 2 weather radars are mobile dual polarization systems that are dedicated to monitor volcanic events. The main parameter we need to measure with the weather radars in a volcanic event is the height of the ash cloud. This parameter is used as the main input in ash dispersion models. To get the most accurate measurements needed of the height of the volcanic plume, we move the mobile radars closer to the volcanic system. We do this when we see increased activity of the volcanic system. We see this from seismic stations and GPS stations. The weather radar is at location, constantly scanning every 5 minutes, so when the explosive phase starts, we will then get real-time data every 5 minutes.
Hello, my name is Elín Björk Jónasdóttir and I'm a meteorologist at the Icelandic Met Office, where I'm also the head of weather services. In this video I'm going to briefly discuss how we use radar for plume detection in the monitoring room. At IMO we've developed a program called VESPA, or the Volcanic Eruptive Source Parameter Assessment, where we use all the available radars we have around the country to monitor active volcanoes. So as soon as there's a volcano that's gone onto a yellow or an orange color code, we make sure that all of the radars are pointed towards that source, or they're moved closer if necessary. And then we run a few algorithms so that if we see a cloud above the volcano that could be an eruptive plume, we can actually see the strength of it and even the height, which is a very important parameter for all of the dispersion models that we use. In this map here we can choose some of the volcanoes that are currently being monitored, and if I press Grímsvötn we can see we have several sets of charts, and we can see the estimated height from several different radars when they are available. This is something that's new and we haven't really made very good use of, since we haven't had a volcanic ash eruption since we started using this. But prior to this system we still had radars that we used, and for example in the 2010 Eyjafjallajökull eruption we were able to detect the plume and the height, and we can see it on this chart here. from the radar that's located at the Keflavik International Airport. Now we have a radar that's closer to that system, so theoretically we should be able to get a better detection and higher frequency of detection of the plume height in an eruption along the south coast now than we did in 2010. So to summarize, in the monitoring room of the Icelandic Met Office we use weather radars to detect plumes from volcanoes, both for dispersion modeling and also for aviation.
For more information about the weather radars, please look at our website.